Hey everyone, this is Anthony Loss with ClearScale. I'll get more into an introduction to myself in just a second, but I am here with AWS today and ClearScale, and we're going to be talking a little bit about application modernization. And this is one of six webinars sponsored by AWS focusing on application modernization. So AWS is doing a lot of efforts to educate their customers on this topic. And I'm so happy to be here today to help along with that effort and share a little bit about what I know about application modernization. And for this particularly, as far as it relates to application modernization, today we are going to be focusing a lot on the common myths of database modernization. So we're going to be hyper focused on database today as opposed to the front end stack of the application. We're going to be talking about how AWS builds databases, how they manage databases, how the cloud in general views databases, and how to best utilize the cloud to debug or debunk these database modernization myths, right? And so we'll go over a number of myths to discuss this, and most importantly, what I'm going to do is I'm going to go deep into real life customer examples to do that and to give you a reference point on what exactly customers are doing today and how they're overcoming these obstacles to get ultimately to a more expedited business flow, a more flexible business, and ultimately offer their customers more products and solutions. So we'll go over a little bit of that today. Quick an introduction to ClearScale and myself. Like I said earlier, my name is Anthony Loss, and I am a solutions architect here at ClearScale, focusing on AWS. I focus all things on AWS, primarily application modernization. I have been an AWS architect for about 8 years now, just under 8 years. And I'm happy to be here at ClearScale, and I'm learning new things about AWS every day. So I'll try my best to communicate that as much as I can to you. As far as ClearScale goes, ClearScale was founded in 2011, and we have 11 AWS competencies. And if you know anything about AWS competencies, you should know that they're very, very difficult to achieve. And so there's a lot of ducks we have to align in order to do that. And ClearScale is happy to talk about these competencies and show them off as they're well earned to be able to do that. So AWS vets their partners really, really well. We're headquartered in San Francisco, California. So that is where the majority of our sales staff lives. But we also are hiring a ton out of the East Coast as well. Myself, I'm located in Chicago. A lot of people guess that off my accent a little bit, my hard O's and A's. So spare me a little bit on that one. But we have resources in all over the United States and delivery resources in the U.S. and in Eastern Europe. So we'll talk a little bit about that coming up. Let's just jump into it. Love to jump into it today and talk about the different myths of database modernization. And we're going to start with myth one regarding there's little to no performance benefits in modernizing my databases on the cloud. Well, let's think about this for a little bit. Commercial databases are certainly falling behind in what they're able to offer their customers as far as processing speed, as far as memory, which is a really, really big one, and as far as scalability, right? And so if you recall, there was a memory shortage available to customers to procure hardware for about a year, and that was about a year ago. And obviously, AWS and the cloud in general were not subject to this because they do buy in bulk. And so the little things, the little intricacies of performance and cores and memory and processing chips and so on and so forth, you can completely waive that from your consideration when moving to the cloud. AWS has that covered, and they're going to make sure they have a overwhelming amount of equipment for you to run your applications and databases in the cloud. Now, I want to take a step away from that. That's the first thing I want to talk about. But let's separate ourselves from processing power and RAM utilization, right? Let's take a step away from that. And I want to talk about using databases at scale. And A lot of customers think, well, if I have a database on premise and if I have a database in the cloud, what's the difference? The database is a database. I'm still going to use this database and that database. So the performance should be the same, right? Well, ideally and theoretically, you're correct. The performance would be the same if it's the exact same database on prem as is in the cloud. But this is where we get creative in the cloud, and it offers you the flexibility to do this is to have scalability in your databases based on demand. And not only that, be able to differentiate databases very quickly and easily based on your application to optimize best performance, as opposed to on premise or in a private cloud, you're sort of bound in to that specific hardware for a certain period of time. And so AWS offers a number of solutions to be able to quote unquote plug and play for your applications, given that they are flexible enough to handle different database engines based on optimization. And sometimes customers like to break apart applications and have one part of the application for one certain database engine and another part of the application for another database engine. We'll have scalability that goes along with that, so on and so forth, to be able to really optimize performance. So it's not necessarily a one-for-one comparison, as it is, okay, how can I optimize performance based into the cloud, right? And so that's where application modernization really comes into play of how to do that. Obviously, you've heard the success stories of Amazon Aurora and how fast it can deliver for its applications, right? It's serverless, so you don't have to manage any underlying infrastructure. You don't have to worry about patching or anything like that. And so Aurora is extremely, extremely fast, both regular Aurora and serverless Aurora. And so I encourage you to do some reading on that and find out, what the differences are and how fast it can deliver speed. But once again, I want to separate the conversation from, hey, how fast is this database or how fast is this serverless database as it relates to what I have on premise, and talk more about how to be cloud native and how to be flexible with certain databases for certain functions in order to achieve high performance and ultimately make our customers happier. Let me talk about an example here. Waves dating app is a company that ClearScale got involved in, and they had a SQL database that they were working with for their application. It was a monolith database, and essentially they were looking for more flexibility. The optimization wasn't great. They were having latency as it scales. They had a lot of queries to execute constantly during the day, and then at night it wasn't so good. And so their customers weren't really happy with how fast the app was working. Well, ClearScale was able to offer a solution via Amazon Neptune. And if you know anything about Amazon Neptune, it's a graph database. And essentially, what a graph database is a NoSQL database that stores data as a network graph. So it prioritizes the relationships between data in a NoSQL format. So they have the ability to grow and scale and use certain data items for certain application functions that they have to implement. And this offered Neptune as a managed service in AWS. It offered unlimited scaling and scale down, right? You only pay for what you use. And also it provided the flexibility to optimize certain application functions based on data items that they need, as opposed to one large database to do everything. Myth number two, cloud databases won't reduce my IT costs. Once again, you can think of this as a one-to-one as theoretically being possible. But also, if you have one-to-one, think about it like this. If I have a database on premise, I have to pay in full for that database, whether if I'm buying it direct or if I have a private cloud, right? I need to make sure that I am paying the licenses, I'm paying for the entire database. Whereas in AWS, you're paying for what you use, right? Whether that's on demand or savings plans or whatever the case may be, there are flexible options to be able to purchase databases in the cloud based on what you need to use. So, for example, if I know I'm using Postgres database and I know I'm going to be using it a ton for at least 3 years, well, we can offer a reserved instance via AWS to really minimize that cost. Or if you're saying, okay, I'm going to use a Postgres database for a year, and I know we're going to use this much, compute, but I don't really know what much else besides that. Well, we can purchase savings plans in AWS to be able to, minimize that cost. And then once again, right, we want to make sure that we're using elasticity. So not one for one. We want to be able to scale up and scale down based on what we are using, and that's what AWS is able to offer. Quick customer case study for this, pest routes. ClearScale got involved with in an engagement, and pest routes is a pest control company. Um, they had on-demand requests for the nature of its business, and it wasn't adequate, right? So they weren't able to grow and scale with the company's growth. They had a bunch of requests every morning that overloaded the database. And then they had a very little requests at, let's say, 1 a.m. or 2 a.m. or at night that they were paying for the database, right? They paid for growth. So the database wasn't able to scale in the morning. And then at nighttime, right, the return on investment was not meeting optimal path. And so the customer's uh, um, contract in the private cloud was expiring in a couple months, and they said, okay, so how do we be able to become more flexible and more scalable in AWS cloud? So our architects were able to talk to them and able to discuss right the scaling that we discussed a little bit earlier. But they were also concerned on the cost. So obviously the scaling is going to introduce less cost, but they had a large application stack that they were also having in other servers that were taking a sufficient amount of cost. And so ClearScale was able to take a look at this application stack, map it to a correct database based on what the application function was, and then able to eliminate necessary files and necessary libraries to ultimately make the total footprint a little bit smaller and ultimately save on costs. And then as a plus to that, the application was more simple or simpler and was able to produce and operate more efficiently. How do we do this? We were able to pick a database. It was an RDS database for this company. RDS is a relational database service in AWS. It can take SQL Server, it can take Aurora, MySQL, Postgres, Oracle, maybe MariaDB, one other one. And it was able to we were able to switch on RDS and then use the certain functions for certain clusters for the application. And then more importantly, we redeployed the application through AWS CI/CD pipelines, which we'll get into shortly here, and able to remove the unnecessary libraries as it relates to the certain database that it was being deployed to. So some of these libraries were, things as config files or package libraries, package bundles, a lot of stuff that's built into that stack that was making the application less effective, right? And ultimately making the application hosting a little bit more expensive. And so as we were able to strip these features, or I should say libraries instead of features, and deploy the application has a smaller footprint than it did on-prem. And along with that was savings plans and RDS instances for reserved instances. We're able to minimize the customer cost. So ultimately, the customer was paying a third of what they were paying in AWS, ultimately making the customer a lot happier. So that's how we were able to reduce costs in the cloud as opposed to AWS having a flexible footprint, modernizing the application, decreasing their footprint, making the application a lot stronger and faster. Jumping into myth number 3. I'm better off leaving my data on premise for security and availability reasons. This is a common one, especially the first part in security reasons. So, some of the things we have here is, the databases don't offer multi-region. Amazon Aurora maintains 6 copies of data, so there's, very little chance of data loss. 99% availability for Aurora, and then, SLA of 5 nines for DynamoDB, which is a NoSQL database. And then AWS databases allow network isolation, encryption at rest, so on and so forth. Now I'm going to get into this a little bit deeper for you guys. Let's say I have a database on premise and it's a Oracle database, and I have a database in AWS, in which case it is an Oracle database, right? Let's say it's Oracle on RDS. And so if I have the database on premise, right, I have a lot of effort to encrypt that data and encrypt the data in transit, define necessary allowances for certain ports. So let's say I want to allow only certain users to SSH into the database versus other users, maybe a junior developer that can't. So I have to manually configure this for a lot of customers. There's a lot of chance for human error to be able to do this. And then obviously to get the documentation, if I have a compliance audit, to get the documentation to show the compliance company, this is what we're doing. That is a manual effort to be able to build that documentation in order to give that to compliance officers. Now let's take a look at the database in AWS. I have the database in AWS. AWS has managed offerings to do encryption. So with literally the flip of a switch, we can encrypt the data inside a database. We can encrypt data in transit with SSL certificates, literally with a switch of the mouse, right? So a click of the mouse, we can encrypt that data in transit with Amazon KMS, or if you have your own encryption key, feel free to bring it. AWS can implement that. And a key thing here is that AWS is able to rotate keys based on a time period that you set, right? So it's automatic rotation. This is a managed service within AWS. It offers 256-bit encryption, which is what the military uses. It's considered the highest level of encryption possible. And AWS has managed services to manage that encryption. Whereas if you had an on-premise, right, you can do that, but you're managing itself and you're introducing the opportunity for human error, right? This is why we're seeing cars being able to self-drive itself and AI being able to do certain functions in business and natural language processing, right? All that sort of stuff is to reduce the opportunity for human error. Well, that's what we're doing in AWS. That's what we're doing as far as security is concerned, is reducing the opportunity to introduce human error, right? Another thing as far as security in AWS, I mentioned, remote access based on who is accessing the server or who's accessing the database. Database access is a huge concern for HIPAA compliant companies, right? Who is accessing database? Who has views of these PII documents for customers? And when you're on premise, you have to manually adjust those roles or manually assign those roles to your Active Directory or your whatever LDAP you use to be able to tunnel into these servers. Well, what if there is an exchange or someone shares their password or so on and so forth, and a junior developer was accidentally given these opportunities to be able to tunnel in, and they printed some PII or left something unencrypted, so on and so forth. That is the issue that HIPAA compliance or HIPAA companies are afraid of. Within AWS, we have a multi approach to this. Multi-factor authentication is one of them, but we also have a multi-approach to this. And what that means is AWS offers a service called IAM. It's Identity and Access Management. And this can apply to users, and it can also apply to resources. So let's talk about IAM roles for users. If I have an IAM role and I have a senior database administrator, they should have access to the database. I assign that role to their user when they sign in. As opposed to a junior developer, maybe they shouldn't have that policy in their role to be able to access the database. So that's one way of doing it. Another way is having a single sign-on, an SSO, to be able to tunnel into the database, right? So if they have single sign-on, they have multi-factor authentication that goes to their cell phone or however they want to do that, their email, and then they log in, and then they have that certain role as it pertains to how they're accessing the database. One extra layer of security with the role. Second layer of security is how folks are engaging in the database. AWS offers security groups along with network access control lists, obviously. They offer security groups that allow certain ports to be able to funnel in. So let's say it's a Linux database. We should allow SS3 from certain ports. Let's say it's just from the senior developer's laptop, right? It's not from anywhere else. They can only SSH in from that laptop, from that IP address to the network access control list, into the security group, into the database, right? These are the flexibilities that AWS offers as far as security is concerned. Real quick, we had a customer called Minted, and it's a marketplace for artists, and they had infrastructure in rack space, and redundancy was limited. So we migrated the database to Amazon Aurora Postgres, and we provided that built-in security. Now, they also had a compliance to be able to have redundancy in different regions. And this is where AWS really came in handy, because we were able to build the infrastructure with infrastructure as code and CloudFormation as a JSON or YAML script and deploy the same infrastructure and data in another region just spun down. So in case of a disaster recovery, we were able to launch that infrastructure within minutes and be able to serve requests. So this includes data replication and a certain infrastructure that you may not be privy to if you have an on-prem environment. Myth number 4. There's not much I can do in cloud databases that I can't already do on-prem. Well, that's not true. So most commercial databases, if you buy, are monolith by design, right? And so there are, they're powerful, no doubt about it, just as they are in AWS, right? If you do one for one, a database can be powerful. But how do we implement microservices into this environment? And so that's how we are revolutionizing databases that you probably can't do on premise. So if you remember back in Myth 1, I talked about different databases for different application functions. And that is what we're talking about for on-premise. Unless you have hundreds and perhaps millions of dollars to spend to be able to offer different database services, meaning you have to procure different databases if you're on-prem or in a private cloud, unless you have that type of budget, it's going to be very, very hard to do that on-prem. Whereas in AWS, you can spin up databases fairly quickly and only pay for what you use. And so this, in correlation to modernizing the application, can enable you to do what you couldn't dream of what you can do on-prem. Modernizing the application is just as important as modernizing the actual backend stack of the database. And so I'll jump into an example here of how we helped a customer be able to achieve what they could not achieve on premise. So we had a customer called Staywell. They were a health engagement company that supports education of health. And essentially, from the bigwigs upstairs, they had an initiative to implement automation wherever possible. I believe their private equity firm was pushing down on them to, hey, we need automation. We've had trouble with another firm that we invested in the past. They had customer downage. They weren't able to serve their customers. Now we're instilling this for all our customers. And so all of a sudden they have this huge implementation automation that they need to achieve. And they were on-prem. And so, automation on premise, while possible in certain areas, not really practical in all areas, and the time to market is not really practical. And so, like most customers, they were reading on how to automate, how to have, a microservice architecture where we don't need to have so much hands-on, we don't need to, do manual patching, so on and so forth. They took a look at Docker, containerizing their applications with deployment. And this introduced some complexities for containerizing those applications. So some complexities were being able to break down the application based on the function, right? If we go back to Myth 3 and Myth 1, you're starting to see a pattern here. And so we were able to, in AWS, through different services, build Docker images very, very quickly without a certain, container build service that they would have to procure on premise. They have to procure it, they have to wait for it to ship, they have to configure it, so on and so forth. AWS, we spun up a CI/CD pipeline. We built a container image within just a couple days. We'll build a container image and deploy it to a container registry that Amazon has. It's called ECR, Elastic Container Registry, and able to instill that image in different containers as they were able to deploy. So now they had an automated deployment that it satisfied the initiative for automation as far as application deployment can happen. They were able to run their application code, any adjustments, they would push the code to the CI/CD pipeline. CI/CD pipeline would automatically kick off, build based on the environmental variables of the code that they're pushing, assign a Docker image to it, deploy the Docker image to their containers, and then most importantly, automatically update the machine image of certain parameters to include that new Docker image based on the last deployment. So all of this was automated. This was not any manual effort to be able to do this. They were able to automate this process, and the only manual effort was to write certain code within their applications to introduce new features, right? That's it. And that's how they are able to achieve that automation. Now, what about the automation on the back end of the stack? Well, once again, we're breaking down databases per application function. And so within that CI/CD pipeline, CI/CD means a continuous integration and continuous deployment. Um, Within that CI/CD pipeline offered by AWS through Code Pipeline, that's their service, we were able to automatically, with a script that was pre-written, adjust the databases based on new features that the application had or contained. And if it was a Windows database, we can introduce a PowerShell script through a custom resources in Code Pipeline to automatically invoke the PowerShell script to make different adjustments to the certain database that that container was aligned to. So they had this originally had a Microsoft SQL database. It was a huge one. We broke it down and assigned it to each container as Aurora PostgreSQL. So now the automation for different features and functionalities and different deployments was that much easier because the database was smaller, right? Decreasing our database footprint is always a good thing, believe it or not. And AWS empowers us to be able to do that and empowers automation to be able to satisfy any initiatives that require automation through this strategy, through the automated CI/CD pipeline deployments, automated patching, automated continuous integration and feature branches and merging and so on and so forth. They were able to satisfy this constraint for their customers and for their bigwigs. All right, myth number 5. So myth number 5 says commercial databases like Oracle or SQL aren't really compatible with cloud databases. Well, let's think about this for a second. Cloud databases through Amazon RDS offers MySQL or SQL Server or Oracle RDS. So their little one-for-one, right, is possible within AWS. And so, but let's take it a step further than that, right? Let's take it as far as what if I were to procure a SQL Server on premise and it's not, we're concerned it's not compatible with AWS databases. There are custom features that you can deploy in AWS through these databases. So if I had an Oracle database that included all sorts of custom plugins that I need to access to the node and so on and so forth, and say, hey, AWS Managed Services doesn't say I have access to the node. Well, that's okay, because I can use EC2 instances to deploy that database in AWS and apply those custom nodes. And you might be saying, well, Anthony, EC2 instances and on-premise, isn't that the same thing? I thought, if we're using the cloud as on-premise, then why would I even go to the cloud? Well, that is a good thought, but let's think of it this way. If I have an EC2 instance with custom plugins that's running Oracle or MySQL, I can still use the managed services that AWS offers throughout. So for example, I can use AWS Systems Manager to provide patch baselines to my EC2 instances that I couldn't use on premise. So there's one headache that's out of the way. Let's say I want a caching service for this EC2 instance. Instead of manually setting time to live or right through caching or manually checking this, right? I can set this once, and Elasticache via AWS can be applied for caching on that EC2 instance, right? So along with that and the certain networking configurations for security, now you're able to have those databases that you're concerned about and you need node access in Amazon via EC2 to be able to configure certain third-party plugins and other features that maybe aren't available in the managed services. But taking it a step further, right? Why are we using those third-party plugins? Why are we making life more complicated than we need to? So let's talk about that. So as far as that is concerned, now we're going to use, once again, back to the pattern, a more microservice architecture. We're going to really apply application modernization. So we're going to apply different updates to the application that maybe we don't need to encumber on our application with these certain third parties. We're much easier to do that. Acoustic was our customer and had the option to either go with SQL Server or Oracle. They chose to eliminate these options altogether and go with Aurora Postgres. Now, obviously, they had all types of third-party plugins. They're a very, very big company, very big marketing technology company. So instead of having third-party plugins to satisfy the whole application, they broke the application down. enable microservices for that application for different databases that align to it. They use Aurora Postgres for this. Um, and we're able to align to certain different applications and adjust the application so we didn't need these third-party plugins, right? But still, if you do need third-party plugins, you're concerned about what's on AWS and how you can configure it, EC2 with managed services in the background, such as automated patching or caching services, is a great option that we're seeing with a ton of enterprise customers. And then along with that, you could use those reserved instances or savings plans that I talked about previously to decrease your total cost. Myth number 6, and our last myth: I have to hire a lot of I have to hire a lot of expensive talent to migrate and modernize my database on the cloud. Theoretically, if you were to hire expensive talent, yes, you would need a person to understand how AWS works and understand how to modernize. But this is where AWS Premier Partners come into play, and this is why AWS has worked with ClearScale to do this presentation for you. ClearScale is, like I said, one of the #1 AWS Premier Partners to be able to offer this service to you as professional services. And professional services can mean a lot of different things, right? Customers may be concerned, like, okay, you build this for us, but we still don't know how to use it. One of the things that ClearScale does is we provide documentation and knowledge transfer to all our customers to achieve full ownership, right? We want the customers to be able to understand the solution better than we do, because at the end of the day, it's the customer's product, it's the customer's service. How are we able to provide that documentation? No, we're not just giving PDF documents and saying good luck. We're doing a do with delivery. We deliver as agile based. We're sprinting to do with. We have half-day learning sessions for every migration that we do. We have a dedicated project manager to make sure the knowledge transfer is being completed to the customer, right? And so as we do this do with delivery, this is how the customer is being able to, one, be a part of the actual design and implementation process. There'll be a open communication for them to do that. And then we have half-day learning sessions as the project continues. So we've achieved this knowledge transfer through different layers of our delivery for our customers to make them satisfied. A little bit good segue into this, right? How we do the migration and modernization practice. We conduct, develop, determine, design, configure, refactor, test, and document. So as it relates to different sort of database offerings, some of these are being used, maybe all of them, maybe none of them. So if we're doing refactoring, well, yeah, that means that the database is going from, let's say, MySQL or SQL Server to Postgres, right? That's going to include a little bit of refactoring. And we want to make sure that we're including that in the design phase. And we want to make sure that our customers are a part of that process, so they know why it's being designed this way. We don't want to take the project, go away, come back in 12 weeks and say, well, we designed it this way, just deal with it. No, we want the customer to be involved in that process to understand why we recommend it. And then ultimately the customer makes that decision. And so as we go through this process, we find it extremely successful with our enterprise and small business customers to be able to deliver this way as a do with approach. Thank you, everyone, for taking the time. I hope you learned a thing or two about database optimization. I really, really encourage you to go to Amazon white papers and Amazon docs to be able to learn a little bit more about this, right? Find your specific use case of what you're trying to do. And AWS has a ton of documentation and a ton of case studies, a lot more than what we went through today, to be able to explain how other customers did it. And then, please get in contact with ClearScale if you have further questions. Our sales reps can direct you to an architect such as myself to be able to answer to the best of our ability, concerns, use cases, architecture, so on and so forth, that you may be thinking about in the future. It's best to get ahead of it now if you are looking to modernize, so that you could serve your customers a little bit more performant in the future. Thanks, everyone.